Okay, so now I am going to show a little bit of an intro into assembly. So I am going to open a part or an assembly that I already have. This is an acronym just to let everybody know. It's a project I'm doing for grad school. I'm just going to pull in the assembly. Okay, so say you made a whole bunch of parts and you want to bring them in to an assembly so you can do whatever you want to do with an assembly. So the first thing you're going to want to do, open up a new assembly and then insert components. And normally it will, if you just worked on a bunch of stuff, it'll be open right here. Right now, I don't know if you can see it or not, but it opened up a basically pull from desktop. And what I'm going to do is pull in the body tube. And what's cool, and this is the Titan submarine, by the way, probably not close at all to what it was, but this was just for a project. So it's following my mouse around, and it's arbitrary in space right now. And if you just want the two origins to line up, you just hit OK. And then it will base everything off of this. So then what you're going to want to do, insert the next component, browse, and then I'm going to pull in the end cap. And then I'm just going to click to place it, and then it's just in space right there. It's not where we want. So to get these two things to be together, you need to mate them together. So this is a very, very simple case. So we're going to want, so coincident is what we're going to start with. Actually, no, I apologize. Concentric. We're going to do, and you'll get good at this eventually once you start messing with it. It will start making sense, but just kind of try different things and it'll kind of all start to work out. If this is obviously how we don't want it, this alignment button is a really good feature. It just flips it over, and sometimes it can get complicated. And if you do get caught up in some weird matrix thing that nothing's working out, just exit out. And the one thing that does bother me about SolidWorks is every single time you do a mate, you have to hit OK. You can't just keep rolling and do a bunch of mates at once. I think it used to be that way and they changed it. And so now that we have these two surfaces, or this surface and this inner surface here, are essentially those two things are seen as circles, and their center points are essentially seen as on the same axis, and that's what kind of makes it concentric. And so now what we're going to do, coincident basically just means touching. So I want this flat surface and this flat surface to be mated, and then I'm going to hit OK. And then there you have it. You got something mated right there, and that's pretty handy. I'm going to exit out of this mate. I'm going to pull in another component. See if I can find it. Should be window. And I'm just going to click. And now it's super cool, and what should work really quickly. See if I remember. Yeah, you just click the two surfaces, and since they're both kind of drafted the same way, it worked out. Obviously, that's not going to work for deep sea exploration because there's a huge gap in there. But yeah, so that's a very simplified kind of intro into assemblies. Let's see. I'll show you guys some more stuff. Let's go into the part. This was a little quick. I guess, I'm sorry. I should have sorted this out a little better. Let's just talk about mates. So parallel is useful for if you just want these two. Yeah, let me just show you what these do. So also, if you need to get into your things that you have, you just delete them. And sometimes they'll have errors and whatnot. But this is irritating because you can't click and drag unless I'm mistaken. But what is nice is once you click one, it becomes transparent, and then it knows you're not talking about the same part. So if I say this and this are parallel, see how it shifts off of the coincident or coincident mate that we had prior, because it's letting you know, hey, this is not coincident. So what you can do as well is you can come into here and you can change it to perpendicular. You can change it to coincident, which is basically just touching in this case, or you can do the forbidden mate, which is lock, which just says this position in space is going to be occupied by this, and that's it. There's no, hey, this is in reference to this. It is saying, hey, this is this. That's what that does. So we're going to reverse that and then exit out, and then I'm going to delete that. And then let's see. Distance mates are super duper handy. So if we want this to be a specified distance away, we can either click, it goes by tenths, so I don't suggest clicking the arrow, and then flip dimension, obviously, if you don't want it to go the way that it went. And then another cool feature, we're going to flip that, is the degree tool, which you notice is also kind of similar to perpendicular, but if you wanted something a little different, obviously you're going to have another constraint on this part for it to be where you want it, and right now I'm not really set up for that, but for a good starter of kind of how simple it can be, whoa, that was weird. I mean, don't get scared by all this stuff. There's the good thing is there's not a whole lot we can do if you're just trying to get things together. Your best bet is just pull some random crap into your workspace and then just mate it up differently, kind of see how things work and how the software reacts to different mates and how things work. And then and later on we will get into bigger and badder assemblies, and yeah, so right now just kind of real quick recap, just insert components, pick your components from your computer, mate. Things have kind of weird names, but it works out. Something we can go over is this handy thing in the evaluate tab is measure. So the trick to reading this is going to be, you're going to get a bunch of different lines, right? So it's seeing the surface and the point that I chose on both selections. So it looks really crazy, but as soon as you move it around, it kind of starts to make sense. It's saying in the x-axis, this point and this point are 40.1 inches, and then same for the y and the z. And so it's kind of telling you how it came up with it. But from surface to surface, which is going to be your normal distance, which is probably what you're going to want to kind of go off of, that's 117.75 inches. So that's really helpful to know. You can also get, and also you can either just click off or just click something new. Or actually, sorry, if you keep clicking things, yeah, best way is just to click off. It'll give you diameter, area, which is really nice, perimeter, all sorts of that stuff, and then it's going to go between the 2 points, obviously. But you can click the line, and it'll just give you the diameter, and see how the center is 0, 0, 0. Because remember when we first started, and we just clicked the OK button, it zeroed the centers, and see how this one is offset the center is, and those are your X, Y, and Z coordinates of that location. So we'll get into mass properties for when before I get into FEA stuff, which will be coming soon. Interference detection, I have not done very much of. Yeah, I'll have to get kind of spun up on that some more. Oh, I think you just do. It should tell you. All right, well, this is all stuff that you can mess with. Right now I'm just trying to get the basics down to where when I start getting more into the higher level stuff, you can kind of follow along more. So yeah, if you have any questions, comments, or concerns, let me know. Thank you.